Hello everyone, let's go ahead and talk about inflection and the shape type of the graph. So let's go ahead and take a look at this particular function that we have drawn here. Notice that it starts up, goes up this way, comes back down, comes down here, comes up here, levels off, and then comes back up again. Okay, what we're going to do is we're going to go ahead and make sure that we can determine both the sign values, whether it's positive, negative, or zero, for both f prime of x and f double prime of x. Okay? So notice that what I've done is I've drawn f prime of x in blue. So what I'm going to do is on the graph itself, I'm going to go ahead and show where the graph has a positive f prime of x value, where the graph has a 0 f prime of x value, and where the f prime of x value is actually negative. Okay, so let's go ahead and see if we can get this. Now notice that we have this here as a horizontal tangency, so I know that at this point here it's 0. Notice same thing here for x sub 2, and same thing here for x sub 3. So what I can do then is everywhere else it's either going to be positive or negative. So let's go ahead and see what happens. So I'm going to draw the positive and negative signs also above the curve so that we can get an idea of what it looks like. So notice that the instantaneous rate of change for all of these are all positive. Then it gets here, and that's at 0, because that's a horizontal tangency. Then it comes down this way, that means that it's negative. And then it gets over here, so horizontal tangency again, and then it becomes positive. Becomes 0 here again, and then notice that in this case over here it becomes positive again. Okay, so let's just go ahead and bring all of those sign values and drop it down onto this one-dimensional line here. So we know that all of these values here are positive values of f prime of x, negative values of f prime of x, positive values of f prime of x, and again positive values of f prime of x. So notice that, remember, what we wanted to do is we wanted to use f prime of x and say that the sign of f prime of x is going to determine whether f of x is actually increasing, decreasing, or stationary. So notice that what we have here is we have something that is increasing, f of x is increasing because f prime of x is positive, stationary here because we know that f prime of x is equal to 0, is decreasing, f of x is decreasing here because f prime of x is negative, stationary here because f prime of x is equal to 0, positive here, f of x is increasing here because f prime of x is going to be positive, stationary, which means that f of x is, f prime of x is 0, and notice that the function f of x is increasing here, which means that f prime of x has to be positive. Okay. So remember also that we said that this would then become a local maximum. This right over here would be a local minimum. And this right over here would be neither. And we called that something else. And we called that an inflection point. So let's go ahead and talk a little bit more about what these inflection points are and what f double prime is. So the sign of f double prime of x, make this a little bit more clear here. F double prime of x determines whether f of x is concave up, concave down, or whether there's an inflection point there. Now we've already talked about concave up and concave down, and I'm hoping that you remember when we first introduced inflection points, as that was when we were dealing with the normal bell curve. And remember that we said that the inflection point on the bell curve is actually where the first standard deviation will always be. So we kind of have an idea, but let's just go ahead and review that again. Now, if your function is looking this way, in other words, it's opening downwards, then we say that the concavity is downwards. Okay, if we have the function opening up this way, then we say that the function's concavity is opening upwards. Now, let's go ahead and take a look at that here. Now, notice that for this particular curve, this part of the curve, if we go up to about here, is downwards. It's going downwards. So that means then if that it is going downwards, if f of x is concave downwards, what that means is that the sign of the second derivative is actually negative. Okay? Now, if we go ahead and take a look at this part of the graph, this part of the graph is actually going to be positive because it's concave up. So what we have to do is we have to kind of get an idea of, well, where does this actually stop becoming concave down? And where does it start becoming concave up? And it would generally be like right about there. Okay, so let's just go ahead and put this point here, and we'll go ahead and label that with an X. So if I go down this way, this is actually where f double prime of x is actually equal to 0. Okay, so that's where it's equal to 0. Now, if I go ahead and take a look again at what happens here, so notice that there's a point where this graph is concave up, but notice that this part of the graph here is actually concave down. So what we're going to have to do again is we're going to have to try to think, well, if this is concave up, all of a sudden it starts to concave down. It starts to go like that. Then it has to be someplace like right about here. Looks like it's about there. Now that point as well is going to be a location where the concavity is actually 0. Now, look at what happens at this particular point here. Notice that the concavity is down, right? This part is down. It's looking like that. And then this part over here is actually concave up because it looks like that. And so we know that this point will also be what is called an inflection point. Okay, so concave up, the sign of your second derivative is positive. Concave down means that the sign of your second derivative is negative. And notice that at this point here, it is concave up again. And so notice that what you have is you have positive concavity. So let's put that on the graph itself. So all of these areas over here is where your second derivative is actually concave down. This part over here is where your concavity is actually concave up. This part over here, concave down. This part over here, concave up. Okay, so that's how we can now go ahead and use also the second derivative to determine better the shape of the graph. So with the first and the second derivative put together, we can actually come up with a graph that should be reasonable to actually put all these points together and to come up with something that is a pretty good representation of the function itself. Okay, so here's what we have. Sign of f prime, again, determines whether f of x is increasing, decreasing, or stationary. The sign of f double prime determines whether f of x is concave up, down, or there's an inflection point. So associate that with what we have here, and you should be able to go ahead and determine the concavity of any particular function that we have. So here's your question for tomorrow, or the next time that we have class. True or false? If f double prime of c is equal to 0, then there is an inflection point at x is equal to c. Is that true or false? If there is an inflection point at x equals c, then f double prime of c is equal to 0. So we'll go ahead and discuss whether which one of these is true and which one of these is false. And we'll go ahead and take a look at how to apply this to functions that are actually given to us as equations. Okay, so give it your best shot and we'll see how you do. Bye-bye.